Okay, looking at one of the uses of radians in our Year 13 Pure course is something called small angle approximations. I've taken this straight from the textbook, pages 133 and 134. And the book's got a couple of better sketches than I've got here. But these give an idea about the three small angle approximations. As long as theta is small, sine theta and theta are approximately equal. If you can imagine a sine curve like that and drawing y equals x on it, close to the origin, these are fairly good approximations. Similarly, cos theta can be approximated as 1 minus theta squared over 2. Around the y-axis, the cos is like a negative x squared curve. So the two curves are very similar there. And similarly, tan theta is approximately equal to theta close to the origin as well, very similar to the sine. Those doing further maths will look at exactly where these come into it. This works as long as we consider anything where we're looking at theta cubed. As long as theta's small, theta cubed will tend towards 0 and will make it not change these approximations much at all. So for example, if you can imagine in degrees, 30 degrees, in radians pi over 6, well sine 30 degrees is 0.5 and pi over 6, 3.14 over 6 is about 0.52. You can see that at that stage there, the value of sine of 30 degrees and the actual radians value for pi over 6 are very, very similar. Smaller than that is an even better approximation. I mean, that's about a 4% error, but less than 30 degrees, less than pi over 6, it's an even better approximation. So let's have a look at some of the examples from the book then. What they do is we want to have rough approximations for functions like this. So if I look at example 20a, sine 2 theta plus tan theta all over 2 theta. Well, if theta is small, so that sine theta is approximately equal to theta, we can say that sine 2 theta is approximately equal to 2 theta. Tan theta is approximately theta, so we can say that this expression here is roughly equal to that. So it's roughly equal to 3 theta over 2 theta, so it's roughly equal to 3 over 2. As long as theta is small, then this expression will tend towards that. If you have time at the end of an examination, you could always stick a small value in for theta, like 0.1. Is always a good one to try, and then you can quickly work out what sine of it is, tan of it is, and divide by that, and you should get an answer roughly like that. For B, here's our expression, cos 4 theta minus 1 over theta times sine 2 theta. And as before, theta small, 4 theta is still classed as being small as well, so we can say that this is 1 minus, be careful with this one, it's got to be 4 theta all squared over 2 and minus the 1 there, and then divided by theta times sine 2 theta is approximately 2 theta. Don't forget to square the 4 is basically what we're trying to say there. So this becomes 1 minus 1, takes care of itself, and then minus 4 theta all squared is 16 theta squared over 2, it's minus 8 theta squared all over 2 theta squared. So that is approximately equal to minus 4. And then on top of the next page we've got example 21a. This quite long-winded show that sine 5 theta plus tan 2 theta minus cos 2 theta is approximately equal to this one. We'll do exactly the same thing. We're going to look at the left hand side and we'll say the left hand side is approximately equal to 5 theta plus 2 theta minus 1 minus, and again 2 theta all squared all over 2, and that becomes 5 theta plus 2 theta, there's our 7 theta, minus 1, minus times minus is plus, and 2 theta all squared is 4 theta squared over 2, and 2 theta squared, and that equals our right hand side. So we're good to go there. If theta is small, then the expression on the right hand side, well, as theta tends towards 0, this expression on the right hand side will just tend towards the constant that's left, the minus 1. The 2 theta squared is very small indeed, the 7 theta is deemed to be small, So we're left with -1. And having seen that, you should now be able to try the exercise 5F on page 134.